Okay, this is the 4 to 6 paper for the 2005 UK SAT papers. I'm just going to do a quick run through all these questions, and at the end of this, the questions specifically for the 4 to 6, it then starts doing questions which are in the 5 to 7, and there are videos labelled based upon the 5 to 7 numbering, so make sure you use the proper links to get to the right questions. This also will overlap with question 8 in the 4 to 6 with question 1 on the 5 to 7, because there's an extra part in the 4 to 6. So write the missing numbers on the number lines. So if I start -8, if I go up 1, it's -7, -6, and this must be -5, 1 mark. If I start at -3, -2, -2, -1, 0, that's 3, 1, 2, 3 gives me 6. If I count down from -3, -4, -5, -6, -7, -8, and we're at -9. So it's counting positive and negative numbers, fairly straightforward, I would hope. Question number 4 is about areas, and you can do areas using the squares to help you. You do not need to know the formulae necessarily for calculating them, although I'll quickly cover them after I've done the question. So the first one is a square, and it is 4 by 4, so it is 4, 8, 12, 16 centimetres. If you heard me say it before, the area of this one is 4 squares by 4 squares. That gives me 4 times 4, which is 16 units. That's how we can calculate the area. This square, you could do it by counting. 1, 2, 3 from these two halves, 4. That gives me one solution. An alternative is to think about the square we had and how much of it has been shaded. So if I copy the shape, there's 1 shaded out of 4, so it's a quarter of 16. A quarter of 16 is going to be 4. An alternative one to that is to actually do it using the area of the triangle. And if you know the area of the triangle, it is the base, which in this case is upside down but 4, times its perpendicular height, which is this height here, 2. So the area.
Do you know where is the printer?
Computer. So if you want to do the area of this using the triangle, it is half the area base times the height. So it's going to be 1/2 times 4 times 2. 1/2 times 2 is 1 times 4, 4. And that's because it's half of this rectangle here, the 4 by 2. So there are different ways of approaching that question. Bottom one we can do, again counting, 1, 2, 3, 4, whole ones in the middle, plus 1, 2, 3, 4, counted in halves, gives me a total of 8. Quickly you can do it by looking at the shape compared to the square, the 16, and if I split it, you should notice that for each shaded part there is a white part the same size all the way around. So half of this shape has been shaded, so 16, half of that's 8. Or to calculate the area of this using shapes is very hard. You have to know Pythagoras if you were to do the length here by the length there. So it's outside the scope of the 4 to 6 paper. Scroll on to question number 3. Add together number 3.7 and 6.5. You can do it in a vertical sum using place value. When I do addition, you will notice I do my carrying downstairs. So all these numbers are going to line up, decimal point, decimal point, decimal point. 7 plus 5 is 12, carry the 1 into the next column. 3 plus 6 plus 1 is 10. That's my solution. Okay, so I can cross out my carry now. A lot of people carry up here. I just find sometimes it gets confusing, mainly when we're doing multiplication. The alternative was to do partitioning add-on. So if I start with 3.7, if I think about my 6.5, if I add 6 to it, that gives me to 9.7. I can add 0.3 to get me to 10, and that leaves 0.2 to do. So it's going to be 10.2, and that's by counting on. Subtract 5.7 from 15.2. The ordering of this is a little awkward. It's starting with the 15.2 on top. That's the starting value. We are subtracting the 5.7 from the start value, not the other way round. So I'm going to subtract them in a column. Again, I'll quickly talk about payback in another colour in a moment if you want, but we'll do borrowing to start with. 7 can't be taken from 2, so we borrow from the 5, and that now means this is 12. 12 subtract 7 is 5. Going past the decimal place, I put it in, point in. 4 minus 5 I can't do, so I borrow from the column next to it. 14 minus 5 is 9. That's 9.5. That's the subtraction using borrowing. Could do the same thing with the counting. Start with 15.2. If I subtract the 5, and that will give me 10.2. Take off the 0.2 to get me to 10. I've still got 0.5 to go, so subtract 0.5, and that gives me 9.5. I said I'd do another payback method demonstration here. Payback allows me to do 15.2, subtract 5.7, and the advantage with payback is you keep yourself very localized in what you're doing. So we're going to borrow a 1 and pay it back below. So 12 minus 7 is 5. 5 minus 5 minus 1 I can't do, so I'm going to borrow and pay back. 15 minus 5 is 10, minus 1 is 9, and 1 minus the 1, nothing, 9.5. Just different methods for working with these sums. Multiply 254 by 5. You might do the grid. It will break down into this similar section. So I'll do the grid in a minute. So 5 times 4 is 20, so carry 2, and I do put my carries below. 5 times 5 is 25, plus 2 is 27, and carry. 5 times 2 is 10, plus 2 is 12, and that gives me my answer 1270. Other people put the carrying above. When you come to 2-digit though, this carrying can get confusing with others. That's why I carry on the line that I'm doing the sum for. Multiplication by grid method, we have 5, and it's got to multiply by 200, 50, and 4. So 5 times 200 is 1,000, 5 times 50 is 250, 5 times 4 is 20, and you add those together, you get 1,270. Divide 342 by 6. I'm going to show the bus stop method. Bus stop says there's a number we want to divide, goes inside, and we put the 6 on the outside. 6 goes into 3, can't, so I could put a 0 here. There's 3 remainders, so it goes into the next column. 6 is into 34, goes 5 times, that's 30, with a remainder of 4. 6 is into 42, goes 7 times, no remainder. So it goes exactly. So we get an answer 57. Alternatively, people use the long division method, so they would actually subtract down below here. 5 times 6 is 30. The 5 goes above. Carry down the 4, bring the next number down. 6 times 7 is 42. Subtract, and we've got 0 left, so we get the 57. The 7 goes above. That's multiplying using dividing by long division. The Russian method I tend to avoid because when we go into decimals, tracking the decimals is a little bit awkward. So we use long and short division. Question 4 is about finding measures and measuring things on scales. So we look at our scale. I want to make this melon. We're up to 1,000 grams. These are divisions of 200. So halfway is 100 more, and that's 900. So that one, you can say 900 grams. When I measure apple and a melon, do the same thing. We're between 1,000 and 1,200. We're on the halfway mark, so that's 1,100 grams. So the melon weighs 900 grams from the first one. The melon plus plus an apple. The difference is 200 grams, so the apple must have been the 200 grams. How many grams are there in a kilogram? Kilo means 1,000 of these units. Kilometers, 1,000 meters. So we have 1,000. Circle it. There's your correct answer. Question 5. There are 2 children of the Smith family. The range in their ages is exactly 7 years. What could the ages of the 2 children be? That means you could do any ages you like as long as the difference is going to be 7. So the youngest could be 0, add 7 to it, 7, 1 and 8, 2 and 9. You could keep going all the way up to 72 and 79. It doesn't matter. As long as the difference between these 2 numbers is 7, we've got exactly the right answer. There are 2 children in the Patel family. They are twins of the same age. What's the range in their ages? If they're at the same age, they could be 5 and 5, or 9 and 9. The difference between these, the range, is 0. Okay, so range talks about largest or minus the smallest. And it's a statistical measure of spread and how much different things change. Question 6. We need to put fractions onto a number line. Now, some of these we might be able to do by positioning. So let's take that one and that point halfway. So we know the fractions 0, a half, 1. I've split this into 4s, so that's a quarter and 3/4. So my first card is 3/4. Next one is talking about 8ths. Well, they're halves again. 1/8, 2/8, 3/8, and we're dividing between the marks and the line. So maybe I should do it on the line. 1/8, 2/8, 3/8, and 4/8, evenly spaced. One of these matches up. There's 1/8. 1/3 is between a half and a quarter. The bigger the denominator with the same numerator, the smaller the value. So down here we're getting to 1 over 20, 1 over 90, 1 over 100. So 1 over 3 is between 1 over 2 and 1 over 4 going downwards. So there's 1/3, and by elimination I'm left with 3/5. The alternative could be, do you know the decimals for some of these numbers? So 3/4 I know by fact is 75. 3/5 I know is 6/10, so that's a 0.6, a little bit more than 0.5, so it puts it in here. 1/3 you may know is 0.33333. Hard to measure, probably better to do it as a fraction, maybe divide the line in 3s. 1/8, not many people know this one off the top of the head, but it's 0.125, which would allow you to place it. Scrolling on to question number 7, interpreting graphs. Bar chart shows answer 27 people. Do you like school dinners? Bar chart shows yes and no. Complete the bar chart for don't know. So to think about this one, I need to think there were 12 people said yes. No was 6 people. I need a total of 27, so don't know must be the difference. 18, that means there must have been 9 don't knows. 9 is between the 8 and the 10, so be as close, accurate as you can, and draw the top of the box horizontally. Because there's no sort of variation grouping between these, there's no idea of somebody being between a know and a don't know in a measurable way. Make sure we keep the columns separate, and they should be the same width. So I'm just going to shade that one in. This shows the yes and no's, and we've got to show the same thing for don't know. So look at the picture. Each of these must mean the same thing as above. So a circle, we've got 4 circles, so 1 full circle is equal to 3 people, missing the key, and we need 1. If we need 9, that's 3 circles. If I'd needed 1 would have been 1/3 of the diagram, so I'd have split it into a third. 2 would have been 2/3. So you do fractions of a diagram to be able to make that work. Question number 8. This is the percentages. This is the part that doesn't appear on the other exam papers. So the other parts I've covered before in others, but I'll quickly go through it. 70% we should recognise as being 70 out of 100. I want to make this something out of 10. What did I do to both numbers? I can divide them by 10. So the top number will be 7. 10 out of 20, so write it as a fraction, must equal some percentage value over 100. What do I do to my two numbers? The 20 is the total, is the 100%. I need to multiply by 5. So this is 50%. Or this is half. So if you recognise this as half, you can say it's a 50%. This one, notice no word simplify. So any fraction is correct. So the first one you could write down is, what is 5% mean? Well, it's 5 out of 100. There's my first answer. You don't have to give it in the simplest form or any other form. And it says, now complete the following sentence using different numbers. Notice still not mentioning simply as possible. So I can take 5 out of 100. If I was to divide by 5, I'd get 1 out of 20. Probably the first answer I'd go for. But you could do just as easily 2 out of 40, or even go the other way and go 10 out of 200. Whatever method and whichever one you find simplest, put it down. The quickest, not simplest. Don't worry about finding the simplest one unless it says the word simplify or in simplest terms in the question. This one doesn't, so we can finish.